Here is the partially completed prototype for the Magnetorquer winding machine. As you can see, the design is missing one chuck, and as such, a large part of this video will be referring to the SOLIDWORKS CAD models. However, the feed translation and passive wire tensioning systems are functional, as is the method of core rotation, and our implementation of passive wire unspooling. Our team's prototype for the Magnetorquer winding machine measures at 18 inches long by 13 inches wide. It features a multi-configurable layout that enables quick modifications as seen by the grid of mounting clearance holes on the base. The device functions by feeding the wire from the spool mounted on this vertical post through the tensioning pulley system seen here, and then coiling the wire around the core consistently by way of core rotation coupled with feed translation. For the initial prototype, the mechanical design needed to be assessed first. Therefore, energy inputs required for core rotation and feed translation are provided by the user via hand cranks seen here and here. Going over a few features of the design, there are two lathe chucks that hold the ferrite core in place during rotation. There is a rack and pinion system that allows the carriage to translate. There is a pulley system that tensions the wire, and there is a spool that is mounted on a vertical shaft that dispenses wire passively. Our prototype can accept any gauge of wire. Per the requirements, a device should be able to accommodate wire gauges between 0.25 mm and 1 mm in diameter. The pulley gap in our design is 3.175 mm, therefore in relation to this evaluation criteria, the device has 100% satisfaction. The chucks can accommodate any size rod, therefore there's 100% satisfaction for this evaluation criteria. The device can accept any core length within the required range of 50 to 70 millimeters. The minimum distance between the chucks is 0 millimeters and the maximum is 83. This gives 13 millimeters of play to fit the core into the teeth. These features give the device 100% satisfaction with respect to this evaluation criteria. Due to the mechanical design, this prototype can achieve near 0% wire diameter deviation. As demonstrated, this gives the device near 100% satisfaction in relation to this evaluation criteria. The two lathe chucks seen here and here clamp onto the ferrite core, ensuring that it remains secure during the entirety of the winding process. When the ferrite core is clamped between the chuck teeth, the faces on said chuck teeth act as natural barriers preventing wires from unspooling as more layers are added to the Magnetorquer. All these features combined could allow 100% satisfaction in relation to this evaluation criteria. To transition between winding layers, only the rotational direction of energy input for the feed translation mechanism must change. With this prototype, only one user input is required per winding layer. This equates to roughly 90% satisfaction. This prototype needs the user to be present in operating the device for as long as the winding takes. Therefore, operator hours is 0% satisfaction, and time required for winding has 100% satisfaction. The cost of this prototype falls well below the $150 budget. The main costs come from 3D printing the lathe chucks, ordering nuts, bolts, and bearings from Magnetorquer, and finally laser cutting plywood for the rest of the features. The upper limit on cost is $90, and therefore satisfaction would be 100% for this evaluation criteria. The two chuck configuration is able to naturally contain the windings of the Magnetorquer. The two chuck design enables the user to specify how much of the core is wound and how much of the core is left unwound.